Welcome back, dear students. We are doing chapter number 21, Trigonometrical Identities, and we are dealing with the first exercise, that is 21A. Okay, now let's start today's session with question number 18. Now here you need to prove that this entire thing will be equals to sec A minus tan A. Okay, so let me take the left hand side. So here, in order to get this, I am going to multiply both numerator and denominator by this quantity. Okay, see, I have multiplied both numerator and denominator by this quantity, isn't it? Now if you call this sec A as A and tan A as B, then this is your A plus B into A minus B, which is equals to A square minus B square, and numerator into 1 will remain as it is. So numerator is this much only, and this is your A square minus B square. Okay, now if you see here, if I use this formula, take this tan over there, you get sec square theta. This goes over there, becomes minus. So sec square theta minus tan square theta will be 1. So that means the value of this will be how much? It will be 1. So whenever this is 1, this becomes sec A divided by 1. I'm sorry, sec A minus tan A divided by 1, which is sec A minus tan A. That's what we wanted to show here, isn't it? So this is your right hand side. You may pause the video and note down the solution. Let's have a look at this now. So again, in this case also you have to do the same. Okay, so basically I am multiplying both numerator and denominator by sec A minus tan A, sec A minus tan A. Okay, now in that case, in the denominator we don't have any problem, because in the earlier problem also we have seen the same. But in the numerator we have sec A minus tan A into sec A minus tan A, which is sec A minus tan A whole square, isn't it? Now we have A minus B whole square. See, you know that this denominator is nothing but from this formula it will be 1, right? Okay, so from this formula it's 1. Now if I apply A minus B whole square formula, this becomes A square plus B square minus 2AB, isn't it? Now anything divided by 1 will be that number itself. So this number divided by 1 will be the numerator itself. Now in our proof, I want tan square only. I don't want sec square, isn't it? So I want to remove this sec square, and for that I am going to use this formula. So sec square A can be written as 1 plus tan square A, isn't it? So if I do that, then this is 1 plus tan square A. We have tan square A minus 2 sec A tan A. Now when you rearrange this, 1 minus 2 sec A tan A first, okay, then we have tan square A plus tan square is 2 tan square A, and that's what we wanted to show here, isn't it? So you may pause the video and note down the solution. Let's have a look at this now. So in the left hand side we have this one, so A plus B whole square formula, right? So apply. In the first one you get A square plus B square plus 2AB. Okay, in the second one also you get A square plus B square plus 2AB. Remember? Now in this I'm going to make use of this formula, because when you get sine here, you get sine theta into cosec theta equals to 1. So that means sine A cosec A will be equals to 1. Okay, now similarly this will also be equals to 1. Okay, because cos A into sec A, using this will be this cos theta comes here, becomes cos theta sec theta equals to 1. That means this is also equals to 1. So 2 into 1 is 2. Here also 2 into 1 is 2. Okay, so that's why this 2 and 2 refers to this and this one. Okay, now others are sine square A. Okay, and we are writing cos square A first. Cos sec square is written later, and similarly sec square A is written later. So this 2 and 2 came from this one and the last one. Okay, now again, sine square theta plus cos square theta is 1, isn't it? So instead of this entire thing, I am writing just 1. So you have cos square A, sec square A, 2 plus 2 is 4. Okay, now for cos square A, I am going to make use of this formula, and similarly for sec square A, I am going to make use of this formula. So if I do that, then this cosec square A can be written as 1 plus cot square A. Okay, so 1 plus cot square A is written. Sec square A can be written as 1 plus tan square A. Now 4 plus 1 is 5, isn't it? Now open up the bracket, you get 1 plus 1 2 plus 5 is 7. Okay, and you have tan square a and we have cot square a. That's what we wanted to show here. So you may pause the video and note it down. Okay, so we have next question. Question says we need to prove this. Okay, so here left hand side is given. Now cos a, if I get this here and take sec theta down, then cos theta will be 1 by sec theta, isn't it? So that's what I have done. Okay, so cos theta is written as 1 by sec theta. Similarly, cos theta is written as 1 by sec theta. Now you might be wondering, why am I doing that? Because in my left hand side, in my right hand side, I want to get sec, isn't it? So from cos, if you want to get sec, then you have to use the reciprocal formula only. Okay, now multiply both numerator and denominator by sec a. So sec a into 1 is sec a, plus is there 1 by sec a into sec a. Sec a gets cancelled, so you get 1. Similarly, you get the same here in the denominator, but you will have minus sign. Okay, now see, we are about to get the denominator, but we have a square in the denominator, right? So to make it square, I need to multiply it by the same number, right? So that's what I have done. See, in the denominator we have this, so I have multiplied denominator with this, and in order to balance, we have to multiply the numerator also. Yes, okay. Now in the numerator we have a plus b into a minus b, which is a square minus b square, that is 1 square is just 1. And in the denominator we have sec a minus 1 into sec a minus 1 is sec a minus 1 whole square. Okay, so we got our denominator. Okay, so now we need to get the numerator. So for that I am going to use, see, sec square a minus 1. Okay, so from there, from this formula, if I take 1 over there, you get sec square theta minus 1, and that's going to be tan square theta. So that's why your sec square a minus 1 will be tan square a, and that's what we wanted to show here. So you may pause the video and note down the solution. Let's have a look at this question now. So again, here what am I going to do is, I'm going to multiply both numerator and denominator by 1 minus sin a, 1 minus sin a. Okay, now 1 minus sin a into 1 minus sin a in the numerator becomes 1 minus sin a whole square. Now in the denominator it becomes a plus b into a minus b, which is a square minus b square, and a square is 1 itself, isn't it? And b square is sin square a. Now again, if you use this first formula, take this sign over there. So cos square theta is equal to 1 minus sin square theta. So 1 minus sin square theta can be written as cos square theta, that is cos square a. Now can I write this in this way? In the numerator also we have square, in the denominator also we have square, so that's why I have written whole square. Okay, and this is 1 minus sin a divided by cos a. Now can I write this as 1 by cos a minus sin a by cos a? Yes. Now 1 by cos a, 1 by cos a is how much? Sec a, isn't it? So that's why instead of this I have written sec a, and sin a by cos a. Okay, so sin a by cos a is here, so this is equal to tan a, so that's why I have written tan a. That's what we wanted to show you, isn't it? So you may pause the video and note down the solution. Okay, so let's have a look at one more question. So this says cos sec a minus 1 divided by cos sec a plus 1 will be this much. Again the rule is same, okay, but this time I'm multiplying both numerator and denominator by cos sec a plus 1. Okay, so numerator is a minus b into a plus b, which is a square minus b square. In the denominator we have cos sec a plus 1 into cos sec a plus 1 is cos sec a plus 1 whole square. Okay, now this, okay, as per this last formula, if you take this 1 over there, you get cos sec square theta minus 1 will be equals to cot square theta. So that's what is done here. Okay, so from cos sec square minus 1 we got cot square a, right? Okay, now what I have done here is cot a, cot a is cos a by sin a, so that's why cot square a can be written as cos square a by sin square a. Okay, now this cosec a is written as 1 by sin a as per this. Okay, and you have plus 1 whole square. Now simplify it. Okay, so basically what I have done here is I have multiplied both numerator and denominator by sin square a. So if you multiply numerator by sine square a gets cancelled, so you have only cos square a. Okay, and this is in fact 1 plus sine a whole square. In the denominator I am talking 1 plus sine a whole square divided by sine square a when you simplify this. Okay, please check it. And when you multiply it by sine square a from denominator and numerator gets cancelled, so you have 1 plus sine a whole square, right? Now that's what we wanted to show here, isn't it? So this is my right hand side. You may pause the video and note down, and these are your homework for the day. So you will do any 5 of your own choice. Thank you very much.